Hello, my name is Paul Gerber, and I am a software developer on the IBM Streams platform team, and today I will be providing an overview of IBM Streams for IBM Cloud Pak for data in a standalone deployment. For this video, I will cover what a Streams standalone deployment is, the different components of the Streams product, and the new cloud-based architecture. To begin, a Streams standalone deployment is first and foremost a Streams product that is run in containers. Specifically, all Streams management services and user applications are run in containers. For those unfamiliar with containers, they are one or more isolated processes with the necessary files and software libraries to run. The environment, files, dependencies, and libraries included in the container are defined by the container image. The Streams standalone installation package provides several images to cover the Streams services and runtime environment for users' applications. Secondly, a Streams standalone deployment has no CPD services or other add-ons included. A standalone deployment is just the Streams product, meaning users can use Streams without a Cloud Pak for data installation. Be warned, however, that administrators will need to provide and configure their own services like monitoring if performing a standalone deployment. And lastly, a Streams standalone deployment requires a RedHat OpenShift container platform or Kubernetes environment. While Streams now runs in containers, it needs a container orchestrator to manage container lifecycles. Kubernetes is an open-source container orchestrator for automating deployment, scaling, and management of containerized applications. RedHat OpenShift is an open-source container application platform based on Kubernetes for enterprise application development and deployment. Now that we've gone over what a Streams standalone deployment is, let's learn about the different services the Streams product offers. The three major components of Streams are the security service, build service, and the Streams instance. The security service is a new component that provides single sign-on support for Streams services. The Streams security service is capable of managing one or more security realms, which is a collection of roles with associated users. Streams services use these roles to determine user permissions. The security service is an easy way to configure roles and users that can be used across multiple services and instances, rather than each having to configure their own security. The build service is a new component that provides a service for compiling and building Streams applications. The Streams build service is composed of a build service container, which uses the Kubernetes REST API to allocate and manage a pool of builder containers that will perform the actual compilations. For security reasons, the builder resources only live for the life of a single build and are disposed of and replaced as necessary. For those looking to create a build service, a security service is required. The third and final component is a Streams instance, which is an application runtime environment. It is composed of a set of interacting management services and application resources. The management services include an application manager, authentication and authorization, logging, application storage, secure application configurations, and web management. For user authentication, instances must be configured to use a security service, login modules like LDAP, or both. Now that we've covered the different Streams components, we'll dive into the implications of the Streams cloud-based architecture. Streams instances, security services, and build services are installed into an environment through Kubernetes operators. Kubernetes operators are composed of a logic controller and a user-defined custom resource that extends your OpenShift or Kubernetes cluster. The logic controller is run inside a project or namespace and can react to events against a custom resource. So, users can create a Streams instance or any of the services within a namespace by creating a custom object that the Kubernetes operator reacts to. The Kubernetes operator creates the necessary resources to bring up the instance, security service, or build service. For a standalone deployment, there is one Kubernetes operator per component. A benefit of Streams in a standalone deployment is the ability to deploy all and multiple Streams services and instances into a single OpenShift project or Kubernetes namespace, provided that all instances and services are uniquely named within the project or namespace. Lastly, Streams does not create Kubernetes resources for applications until a job is submitted, and those resources are specific to the job. This means Streams will only create application resources when it is required for a job and will release those resources if the job is canceled. Additionally, users can now control the compute resources for Streams jobs, processing elements, or individual operators. Users can also create customized application images if their jobs require specialized or new software not included in the default application runtime image. That's all I have for today. If you'd like more details regarding any of these topics, do consult the Streams documentation for more information. Thanks for watching.